Hello there, ICS2O folks. Um, Hopefully you've got a word processor open, probably Smart Notebook because we can copy and paste some pictures then. Um, this is our start to Turing. Um, Turing is a programming language, what's called a high-level programming language used to teach high school students how to write programs. So this isn't necessarily used to write software in the real world or anything like that, but it'll help us learn how to program and get us used to writing our own code. It's not drag and drop um, like Scratch. So this is actually us having to type, and we'll see that soon. And probably you've got me and your note, and you're going to have Turing going in a second. So you're going to be pausing, stopping, going back and forth quite a bit between a bunch of stuff. So open Turing by double-clicking on the icon in the network applications, or you can find it there. And I'm doing this from home, so I can't help you find that. But it's in the same spot that you use to find Scratch all the time, and it looks like that. Looks like that little thing there. And if you want to get a picture of it, you can use the picture tool, but I'll show you, remind you how to do that later. Like it says here, it may be a good idea to copy a shortcut onto your H drive for easy access. So I'm hoping that you can get that open and follow along while we're doing today's note. And there's mine. I've got Turing open there, and we're gonna do our first program soon. But we can see that it's nothing fancy like Scratch. It's just like a blank screen ready for us to type, and all the menu settings that we'll see, and some buttons here too that we'll use soon. Great. So what is the next thing that we want to do here? When you open Turing, you get the edit screen. This is where we type our programs. And so if you want to get a picture of that in there, let's get some typing in there first. It says we're going to do our Hello World program. It's the first program that we always write in a new. We don't have to, but that's the one we do. This is my very first Turing program. Notice that I put that little percent sign there. That percent sign shows that this is a comment. And I'll get back to the note in a second so you can see that. But if I were to delete that, everything turns blue. And that means the blue stuff is what Turing tries to execute. But this is just a sentence. This is a comment. And so we want to do that. And then on the next line, we're actually going to have a command. So we're going to put hello world. And notice I put that in quotes. It turned red, so it recognized this is a message that we're going to print out. It recognized it being Turing, recognized the word put, and it turned it black, so it recognizes that as a keyword. And then when I press run, this is the output screen. So this is kind of like the result. In Scratch, we would have thought of this as the stage. Now, I realize this isn't exactly Flappy Birds, but this is your first Turing program. Congratulations, you've written your first Turing program. So let's get back to the note and take a few things down about the note. Oh, I was going to show you how to get this in there. Remember the picture tool, there it is, and then if I click back on Turing, then I can use that tool to highlight whatever I want to have in my screen, and it's going to go right over. I realize, but so then I shrunk it down by using this, and then I had it right there. I got it right on top of it. And then here's some typing I want you to put in your note. The first line is a comment. The percent symbol tells Turing to ignore the line that no executable statement will appear. So that's all just for us to read. And we'll talk about why we would put comments in later. Okay, so and what sorts of things we should have in our comments. The second line outputs the statement hello world to the screen. Easy peasy. Now, what's the next thing I have in my note here? Okay, when we click run, I'm going to cover up some of this stuff so we can't get too far ahead of ourselves. When I click run, the program runs, and if there are no errors, the run window appears. So this was the output screen. Error messages will prevent your program from running. Read the error and fix your code. So if you goofed it up somehow, you goofed up, and I'll show you a few things, ways that you might have goofed it up. And that's okay to goof it up. That's part of programming, is to goof things up. So for instance, if you forgot the quotes, the end quote, and ran it, this is an error, right? Compilation errors, whatever compilation means. Well, we know compilation sounds like compiler, which we talked about in our hardware software unit. There was one error. Notice down here it actually tells us string literal ends at end of line. Well, what does that mean? Well, we don't know much about that yet, but something's going on in this line, and it tells me line 4 of 3. Um, saying, well, we need to find the end of this message, and I'll do that by putting my quote back in. Now it'll work. Notice if I forgot both quotes, it turns a different color. This blue color is actually what's reserved for variables in Turing, and we won't talk about variables today, but we'll talk about variables soon enough. And if I try and run that, notice I can hit run here, or I can hit the run. It says hello has not been declared, whatever that means. We don't know what that means yet. We'll get to that soon. But notice I wanted a copy of the error messages in your note too. So let's copy that into our note, and we're going to put that down here. And so this is a message for us to figure out how to fix it. So read the error, fix your code. Hopefully we would know to put quotes in there. Now notice, that doesn't mean that we have to put messages. We could put other things, and you don't have to write this down. We'll get to it in a second. So we could put things like, we could put a number, right? And notice that it's not blue, so it's not a variable, and it's not in red, so it's not a message. It's not what's called a string. It's the number 34. And in fact, I can put in expressions that it will actually calculate that. I can use Turing as a calculator. 34 plus 23 is 57, and if you don't believe me, pull out your calculator, but yes, indeed it is. And it'll do that. Now notice, what happens if I put it in quotes? If I put it in quotes, then it becomes a message. Now it's a message, right? It actually put out the letters 3, 4, a plus sign, and 2, 3. And notice if I actually want to combine a message and a calculation, now I just put a little comma there. The little comma lets me put more than one output on a line, and 23, and then it's actually going to do this calculation. 34 plus 23 equals 57. This part was message, and this part was calculation. Okay, I'm pretty sure I have this back in the note, and you're going to get a chance to play with this. So if you never got a chance to play with that, you will soon. Next little bit of note: math and Turing. The front slash is divide. The star, called the asterisk, is multiply. 2 stars is exponents, and SQRT is a square root. So I want to just show you how that works real quick. And you're copying the note, that's fine. But and I can put more than one put statement. I can put as many put statements as I want. So if I put in like 24 divided by 3, and I want to put that out, and I want to put 5 times 12, and if I want to put, let's put 2 to the exponent 5, and then I also want to put square root of, what's the good square root? Square root of 25. So there's all of my put statements. There's the first one, which actually was nice. It had a message. I should have messages for these ones, but I just wanted to show you how it does some math. 8, 5 times 12 is 60. 2 to the exponent 5, I guess, is 32. The square root of 25 is 5, and there. Turing can do some math. Awesome. Let's see, how am I doing for time here? Not bad. I only have a minute or two left. I'm going to keep going. Formatting output. And by the way, formatting output will be our task for quite a lot of our programming thing. We'll always want to make sure the output is formatted perfectly. So we can output more than one item by using a comma, and I showed you that already. We can ask for the item to be placed in a certain size field with a colon. A second colon gives the number of decimal places. So for instance, this is confusing without an example. I want to show you this in an example, and we'll type one in there soon here. Um, by the way, if I wanted just to copy a bunch of code, edit, copy, and then I could just edit, paste, and notice that it also has the same um, quick keys as normal Windows. Now I didn't actually want all that. I wanted all that gone except for the divide. I want to show you this. So if it doesn't go evenly, say it's I got 27, 25 divided by 6. And I press run. And it gives me a bunch of decimal places and it rounds off at the end. Let's say this was money and I actually wanted it to not appear here. I wanted it to have a few spaces in there. So what I could do is tell it the field size. So I want it to be in a field size of 10. So the field size that'll output will be 10 units long. And say I wanted 2 decimal places instead of, what did it have, 6. There. From here to here is 10 spaces. That's that 10. And 2 decimal places is this number of decimal places there. It's formatted the output and tidied it up a little bit. That looks better. Okay. And I think I've got an example here. Example, put 8 divided by 3 is 8 divided by 3 and then 5, 2. So, by the way, if I just copied that, and I'm going to run it in Turing just to see that I'm not lying to you here. 8 divided by 3 is, then there's a little space in there, 2.67. There's a little space in there because we left one space there, but where's the 5 characters, the 5 character field? Well, count them with me. 1, 2, 3, 4, and then there's another little space there. So there's actually 2 spaces there. 1, 2, 3, 4, 5 spaces that calculation was jammed into. All right. And then I put that in your output as well. Okay, I think that is it. Nope, not. Oh yeah, that's right. Comments about comments. This will only take a couple of minutes as well. Comments help us understand variables, code, and programs. Again, remember, if I'm going too fast, you can pause me and type and keep up. Comments should appear at the start of the program, which is called a header. At the start of the program, it should have a header that includes the name of the program, the purpose of the program, the author, and the date or version. So I should have, even though this was just a small program, the name of the program was Hello World. And the purpose, Introduction to Turing. Author, Forrestal. Date is, what's today? Today's day 24-ish. Something like that. And notice that all that's in green. That's all comments because we've got the percent signs there. Why else do we use comments? We use comments to explain use and meaning of variables. Well, we haven't talked about variables yet, but I will remind you of this when we do talk about variables to comment them. Explain chunks of code and individual lines of code. So, I mean, obviously our programs aren't that big yet, but remember our Scratch programs weren't very big when we first did them, and then they got quite complicated. And our Turing programs are going to start small and get big fairly fast. By the end of the week, first week of programming in Turing, we're going to get to do some pretty cool stuff. So for today, we're just taking baby steps, getting used to the idea of Turing and making some mistakes and fixing them and working forward like that. Okay, that's it for Hello World. Remember to save your note And then the program that you're working on, you can actually use this to do the exercises for today, and that's what's next.